Hello everyone, my name is Rishi and today I'll be walking you through my implementation of a bank's account management API. I was tasked with building a transactional API leveraging event sourcing and command query responsibility segregation, which is also known as CQRS. So I built this leveraging Java 17, Spring Boot, the Axon framework, and PostgreSQL running in the Docker container. So the traditional problem is the traditional CRUD systems override data, losing historical content. By using the event sourcing, every single change like deposit creation and closures is stored as an immutable event. This gives us an 100% reliable audit log, which is crucial in financial domains. So this architectural pattern is exactly what is used in modern banking ledgers, trading platforms, and large scale e-commerce orders systems, where a reliable sequence of facts is legally required. So now let me show you the docker-compose YML file. So in this, my system physically splits the writes from the reads uh, with the help of CQRS. So when a user wants to change data, a command like depositing money, it goes through the command gateway to my bank accounts aggregate. The aggregate validates the business rules and if successfully emits an event like a money deposited event. This this event is appended permanently to the PostgreSQL event store. So then my query side, the projections listens to this events asynchronously and builds optimized read models like updating create account view jpg entity. So I choose this approach using the Axon framework because Axon provides first class primitives for DDDs and CQRS. Instead of default Axon server, I configured it securely persist directly into PostgreSQL to demonstrate how events are sourcing operates manually at the persistent layer. So now let me show you the code and tell you what's happening about that. So here you can see the code. The code is divided into core API for the commands and events, command for the aggregates, and then next query for the projections, and the APIs for the controllers mapping API request. So now let me show you the bank account. Yeah, yeah. So this is the aggregate route. Notice how the command handler. Yeah, here you can see the command handler, right? So this command handler methods that perform business logic, like checking if the account is already closed before withdrawing, and the event sourcing handler methods that actually mutate the state, like this dot balance is equal to this dot balance of subtract. So in this way, and then next the current account current account view projection. So that will be in the projection. Yeah, current account view projection. So uh, this this handles the read side. Notice the event handler annotations, right? So yeah, here you can see the event handler. When it hears a money deposited event, it simply grabs the current view from the Spring Data JPG repository and updates the balance number. And later, uh, when you can see like in the bank account controller. Yeah. So here you can see the bank account controller. Here you can see the command gateway dispatching my commands, and directly underneath the standard JPJ repository serving my get read queries. It's completely segregated. So The most challenging part of this assignment wasn't the basic CQRS flow. It was figuring out the temporal query execution and snapshotting it. So, uh, for example, requirement of 10 required me to get the account balance at a specific point in time. So I couldn't query my projection for this because projections only store the latest state. I solved this by querying the event store directly in the controller using event stores dot read events account ID. So I streamed the raw events locally, filtered out any event that occurred after the HTTP method timestamps, and reapplied them sequentially onto an empty in-memory bank account object. Sorry, it's perfectly recreates the account states to exactly that millisecond. After bug I faced was handling exceptions triggered inside the aggregate, like insufficient funds exception, and the next Axon wraps this internally in the command execution exception. Okay, so I built this a custom controller advice uh, in the global exception handler. Here you can see, right, in the global exception handler I have written the controller advice that recursively unpacks the cause chain of the exception to identify business logic failures and return a clean 409 conflict to the user instead of a generic 500 error. So right now the system uses PostgreSQL for both the event store and read models. While this is a great for a monolith, under extreme global load, querying a standard relational table as a append only event log might become a bottleneck. So if I were to improve this, I would extract the projections into completely separate microservices. I would also switch out the PostgreSQL event store for Axon Server or stream events through an Apache Kafka topic. This would allows hundreds of different microservices, for example, like an email notification service or fraud detection service, to independently listen to events like money withdrawal event without ever impacting the core bank's API performance. So, uh, so now let me show you how it runs. Okay. So here you have seen this entire code, right? Now I have defined here. Wait. I have defined the port number here. So here you can see the server is running on the port number 8080, and here the database is running in the port 54232. Here we'll describe everything related to the server. Okay, so now let us run this. Let me demonstrate you to you. So here there are a few commands like uh, I have already written the endpoints. I have already defined the endpoints in the postman. So here in the create account, you can see here I have this endpoint creates the account by using the post method. When we hit this API, it automatically creates an account for a user with a account ID. So now let me hit this API. Yeah, here you can see this it have created a account. It have given me an account ID with created me an account and given the account ID. Now let me copy this, and now let us view the current balance. Okay, so before that we need to, here I have already defined here, right? So let me set the variables of this. Okay, yeah, okay, so I have already set this variable. Now let me hit this. So yeah, here you can see I have actually what happened is I have hard coded this value uh, because when I retry to always this it need to generate the owner name and balance status, all these things, right? So I have hard coded the values by using this, like the owner name always to be like John Doe, and the balance to start with 1,000 rupees, like that. So here you can see like the account is in active state and it, with a balance of 1,000, right? So now let us deposit a certain amount. Okay. So here I have, while testing, I have already written the amount as 500 rupees. So for this, the endpoint is deposit. Okay. After that account ID. Now let me hit this API. Now we are depositing 500 rupees, means it goes to 1000 to 1500 rupees. Yeah, so it has shown me like status okay. Now let us check the current balance again. Yeah, here you can see that it is showing like 1500, right? Now let us withdraw some amount of money. Okay. Yeah, here while already testing I have written like 200 rupees. So then when we withdraw 200 rupees amount from the 1500 rupees, then it will be 1300 rupees. So now let me hit this API, and it shows like the status is okay. And now let me check the balance again. Here you can see it is showing like 1300 rupees. So that means all these three four APIs were working properly. So before going into this, let me show you like the full event history of this particular account ID. Okay, so when I click on this, you can see like the account has been created. And then next here you can see like a money deposited event and money withdrawal event. So all the transactionals, like all the events, are full event history will be shown here using this API. So to check a specific I mean, if you want to check balance at a specific time, here you can go to this endpoint, and you can set the time here. So for example, now today's date is, actually when I was testing here, I have made some changes here. So like let me show you. Now today's time and date, let me set it. Yeah, now I'll set this to 1 minute bank. Okay, so that means 10. And yeah, this is fine, that's fine. Now let me hit this. It is showing like the balance is 1300 at that certain moment, at that certain time. So what happens here is, now if I change this to 05, I mean like 12.5, it shows the balance after this certain timestamp. So the transactions, like see here, you can see we have made the transactions, the balance at that moment was 1350. Like that we can find out the balance at a specific time. And then next here you can see like close account, right? Here this what this endpoint does is it closes the account. Okay, so before that let me run this. Yeah, okay, no problem, we can run this. So here it is showing like account must be 0 to close. Yeah, so if a user wants to try, actually why have I interrupted before is, uh, I just want to show you this error, and then I would like to continue with withdrawing the entire amount, and then we can close this account. So I have previously discussed with you, right, the 409 conflict. So when a bank account has a certain amount of balance, then a user cannot close that account. So before that he need to withdraw his entire balance amount, then only he can close that account. So now let me withdraw the bank account, I mean withdraw the entire balance. That would be 1300, right? Yeah, now let me hit this API, and it is showing me like, yeah, the API was successfully hit. Yeah, now let me check the balance. Yeah, now it is showing like a zero, right? Now let me close this account. Yeah, it is showing me like status okay. Now when we go to this, and when I hit here, it is showing like the status has closed. So that means here everything was working. So when we see here the replay projections. So what happens here is, you can see here, right, in the code, I have already written the shell command. So here it returns, what happens here is, it triggers event replay for the account current account view projections. So it displays everything, current application progress, like everything like that. Now let me hit this API too. Yeah, here it shows like replay started for the projection account views, and like that. So now it starts again. So if the due to this CRUD operations, if it overwrites the data, then this by running this by hitting this API, it would replay the projections again. So that's it. Thank you for watching.